Dear students, I welcome you all for this revision of current electricity pertaining to circuit diagrams. We shall see certain problems which are probably asked in the board exam. Hence, as you see the circuit diagrams in each problem, I expect all of you to focus on the circuit diagram as I explain the steps related to the circuit diagram to arrive at the solution. Now let's get started. The first problem. Three resistors of 2 ohm, 3 ohm and 4 ohm are connected in series and parallel. Draw the arrangement and find the equivalent resistance in each case. The series and parallel arrangements of resistors are as shown. We know in series the equivalent resistance is Rs is the sum of the resistances. So R1 plus R2 plus R3, which is 2 plus 3 plus 4, which is 9 ohm. And in parallel connection, if the equivalent resistance is taken as Rp, then 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Therefore, 1 by Rp is 1 by 2 plus 1 by 3 plus 1 by 4, which is 13 by 12. Or the effective resistance or the equivalent resistance in parallel connection is 12 by 13, which is 0.92 ohm. Second problem. Here we do not have a circuit diagram, but the problem is what resistance must be connected to a 15 ohm resistance to provide an effective resistance of 6 ohm. Now the given data is R1 is 15 ohm, R2 to be calculated, and the effective resistance is given as 6 ohm. Students, please make a note. If the effective resistance is decreased, then R2 must be connected in parallel with R1. Therefore, Rp is 6 ohm. In parallel combination, Rp is given as R1 R2 by R1 plus R2. Substituting the values, we get 6 is equal to 15 into R2 by 15 plus R2. Now rearranging, we get 6 into 15 plus R2 is 15 R2, or 90 plus 6 R2 is 15 R2. Now bringing the values of R2 on one side, 15 R2 minus 6 R2 is 90, or 9 R2 is equal to 90, or R2 is 10 ohm. Thus, a 10 ohm resistor must be connected in parallel with a 15 ohm resistor to obtain an effective resistance of 6 ohm. Three resistors of 6 ohm, 3 ohm and 2 ohm are connected together so that the total resistance is greater than 6 ohm but less than 8 ohm. Draw a diagram to show the arrangement and calculate the total resistance. Since total resistance is to be greater than 6 ohm, therefore 6 ohm resistor should be in series with the other resistors, the equivalent resistance of which is less than 2 ohm, so that the total resistance is less than 8 ohm. Now, to have a resistance less than 2 ohm, the remaining 3 ohm and 2 ohm resistors should be combined in parallel. The arrangement is shown in the figure. For resistors of 2 ohm and 3 ohm in parallel, the equivalent resistance R1 is given as, Rp is given as 1 by Rp is 1 by 2 plus 1 by 3, which is 5 by 6, or Rp is equal to 6 by 5, which is 1.2 ohm. Now this has to be connected in series with a 6 ohm resistor. In figure, the resistors of 6 ohm and 1.2 ohm are in series. Therefore, the total resistance of arrangement is 6 plus 1.2, which is 7.2 ohm. Please note, this is less than 8 ohm but greater than 6 ohm. 4 resistors. Look at the diagram, the first diagram. 4 resistors, each of resistance 2 ohm, are joined end to end to form a square ABCD. Follow the circuit diagram. Calculate the equivalent resistance of the combination between any two adjacent corners. Now look at the figure. It shows four resistors, each of resistance 2 ohm, joined end to end to form a square ABCD. We are to find the equivalent resistance of the combination between the adjacent corners A and B. Between A and B, there are three resistors in the arm AD, DC, and CB in series in one branch. The equivalent resistance of this branch is RS is 2 plus 2 plus 2, which is 6 ohm. Now one resistor, that is 2 ohm in arm AB, is in parallel combination with the equivalent resistance RS, which is 6 ohm. Therefore, the equivalent resistance between the points A and B, as in figure, is 1 by Rp is 1 by 6 plus 1 by 2, which is 1 plus 3 by 6, which equals 4 by 6. Therefore, the resistor in parallel combination is 6 by 4, which is 1.5 ohm. Look at the circuit diagram. The resistors of 4 ohm and 6 ohm are connected in parallel. The combination is connected across a 6-volt battery of negligible resistance. Draw a circuit diagram. Calculate the total resistance of the circuit, the current through the battery, and the current through each resistor. So we need to draw the diagram for the circuit, which is as shown in the figure. Now, if the resistance of the parallel combination is Rp, then 1 by Rp is 1 by 4 plus 1 by 6, which is 3 plus 2 by 12, which is 5 by 12, or Rp is 12 by 5 ohm, equaling 2.4 ohm. Now let the current through the battery be I. Then I is by definition V by Rp, which is 6 by 2.4. So the value of current is 2.5 ampere. In order to find the current through each resistor, the potential difference across each resistor V is equal to 6 volt. Since it is a parallel connection, the volt will be the same as of the battery. Since they are in parallel, current through 4 ohm resistor I1 is V by R1, which is 6 by 4, which is equal to 1.5 ampere. Now the current through the 6 ohm resistor will be I2, which is V by R2 is 6 by 6, which is 1 ampere. Now note that the total current I is I1 plus I2. The circuit diagram shown in figure includes a 6-volt battery, an ammeter, a fixed resistor R1 of 2 ohm, and a resistance wire R2 connected between the terminals A and B. Calculate the ammeter reading when the wire R2 is of 1.2 meter length and of resistance 4 ohm, 0.4 meter length of the same thickness and in material as in case 1, and finally 0.2 meter length and area of cross section double that in case 1. So now when we want to calculate the current, let us see the given values. Resistance R2 is 4 ohm. Total resistance of the circuit will be Rs is R1 plus R2, which is 2 plus 4, which is 6 ohm. Now by Ohm's law, current is V by Rs, which is 6 by 6, this is 1 ampere. Now on doubling the length, the resistance of wire R2 is double, that is it becomes 8 ohm. The total resistance Rs is now 2 plus 8, which is 10 ohm. Therefore the current is 6 by 10, which is 0.6 ampere. The third condition, on doubling the area of cross section, students understand the resistance of the wire R2 is reduced to half its value. So therefore it becomes 2 ohm. Now the total resistance is 2 plus 2, 4 ohm. Therefore the current is 6 by 4, which is 1.5 ampere. In this problem, three resistors are connected to a 6-volt battery as shown in figure. Now we need to calculate the equivalent resistance of the circuit, the total current in the circuit, and the potential difference across the 7.2 ohm resistor. So let's see the first question. Equivalent resistance of 8 ohm and 12 ohm connected in parallel is 1 by 8 plus 1 by 12, which is 5 by 24. Therefore, R1 is 24 by 5, 4.8 ohm. Now, the 4.8 ohm and 7.2 ohm are connected in series, and the total resistance is given as R is equal to 4.8 plus 7.2, which is 12 ohm. The second question, here the value given for voltage is 6 volt and we know R is 12 ohm. Therefore, the total current in the circuit I is V by R, which is 6 by 12 equaling 0.5 ampere. The potential difference across 7.2 ohm resistor is V is equal to IR. Therefore, 0.5 into 7.2 will give the value of the voltage, which is 3.6 volt. Look at the diagram. Three resistors are connected to a 12-volt battery as shown in the figure. The question, what is the current through the 8 ohm resistor? What is the potential difference across the parallel combination of 6 ohm and 12 ohm resistor? What is the current through the 6 ohm resistor? Now let's answer to the questions asked. The equivalent resistance of 12 ohm and 6 ohm connected in parallel is given as 1 by R1 is 1 by 12 plus 1 by 6, which is 3 by 12 or 1 by 4. So therefore R1 will be 4 ohm. R1 and 8 ohm are in series and their equivalent resistance will be R is equal to 4 plus 8, which is 12 ohm. Now current in the main circuit I is V by R. Substituting the values for V and R, 12 by 12, which is 1 ampere. The current in 8 ohm resistor is also 1 ampere. Now the second question, the potential difference across 12 ohm and 6 ohm resistance connected in parallel is V1 is I into R1, which is 1 into 4, which is 4 volt. Now the current in 6 ohm resistor I1 will be V1 by 6, which is 4 by 6, equaling 0.67 ampere. Two resistances 2 ohm and 3 ohm are connected in parallel and a potential difference of 12 volt is applied across them. Draw the circuit diagram, find the equivalent resistance in the circuit and find the current flowing in each resistance. So we draw the circuit diagram as shown. Now the equivalent resistance is given as 1 by R is 1 by R1 plus 1 by R2. Substituting we get 1 by 3 plus 1 by 2, which is 1 by R is 5 by 6 or R is 1.5 ohm. We know by Ohm's law V is equal to I into R, or I is V by R. For R1 being 3 ohm, then I1 is equal to 12 by 3, which is 4 amperes. And for R2, which is 2 ohm, I2 will be 12 by 2, 6 ampere. What is the current flowing in each of the three resistors in the circuit shown here? Calculate the total resistance of the circuit. In the given figure, the 10.5 ohm and 21 ohm resistance are connected in parallel. So the equivalent resistance can be calculated as 1 by R is 1 by 10.5 plus 1 by 21, which is 3 by 21 or 1 by 7. So the total resistance is 7 plus 5, which is 12 ohm. The current drawn is V by R, which is 3.6 by 12, which is 0.3 ampere. Current through 5 ohm resistance is 0.3 ampere. Current through 10.5 ohm resistance is 0.3 into 21 by 21 plus 10.5, that is IR1 divided by R1 plus R2, the formula. So 0.3 into 21 divided by 31.5, which is 0.2A. The current through 21 amperes is 0. The remaining value will be 0.3 minus 0.2, which is 0.1 ampere. Now, this kind of questions, students, please make a note. It will be asked as a 2 mark question. So you need to be very fast in making an analysis and apply your knowledge on the value of series connection and parallel connection, and then attend the question. Which of the two combinations shown here has a higher resistance between the points B and C, and by how much? So look at the diagram. For A, 1 by 1 by R equivalent is 1 by 3 plus 1 by 6. This is got by having the connections between BA and AC as series, and B and C as parallel. So 3 by 6 is equal to 1 by 2, or R equivalent is 2 ohm. Now for the circuit B, we have 5 ohm and 10 ohm in series, and 8 ohm and 2 ohm in series, but these two are parallel to each other. Therefore, 5 plus 10, 15, and 8 plus 2, 10 ohm, which are in series connection. Now we need to calculate the equivalent resistance in parallel, which is 1 by 10 plus 1 by 15. On simplification, we get 5 by 30, which is equal to 1 by 6, or R prime equivalent is 6 ohm. The combination B has a higher resistance between the points B and C. Now look at this question. A combination consists of three resistors in series. Three similar sets are connected in parallel. If the resistance of each resistor is 3 ohm, find the resistance of the combination. Since three resistors connected in series, their equivalent resistance would be R1 plus R2 plus R3, which is 9 ohm. Also, three such combined resistors are connected in parallel. Hence, their equivalent resistance, applying the formula, is R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. Please make a note of this formula when you want to find the effective resistance of three resistors connected in parallel. So that is R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. That is, since the value is 9 for all, so 9 into 9 into 9 divided by 81 plus 81 plus 81, which is 729 by 243, which is 3 ohm. Students, that brings us to the end of this revision session on the circuit diagrams. We need to practice more of this type of circuit diagrams once you become used to applying your mind and having a better understanding of the connections in series and parallel. You become more confident in attempting any such problem asked in the circuit diagram. Bye till we meet. Take care. Stay safe.